I'm going to tell you a little bit about some exponential laws in this video. I'm starting off with this chart right here, and you can see that we've got 10 to the third, 10 to the second, 10 to the first, etc. And eventually we go down to the negative values. Now, 10 to the third, I think that you might know this from prior math knowledge. It means 10 times 10 times 10, which is 1,000. A popular misconception is for students to multiply the exponent by the base, so the exponent here is 3, the base is 10, and say that the value here in standard form is 30, but that would not be correct because the exponent is telling you how many times to multiply the base. So when you get to 10 to the first right here, it's really telling you multiply 10 one time. Well, in that case, you're really not multiplying it, so you just leave this as 10, and therefore in standard form there's nothing to multiply. We can just write 10 here. So if the exponent is telling you how many times to multiply, what does a negative exponent mean? Well, a negative would be the opposite of positive, and if these were all positive, and these are telling you to multiply 10 two times, when we use a negative exponent, we're going to be really dividing 2 times. So the way this will look is you've got 1/10 times 1/10 here. So you've got two bases of 1/10, and the reason that these are fractions is because the exponent is negative. So in standard form, 1 times 1 is 1, and then 10 times 10 on the bottom there, your denominator will be 1/100th. And likewise, this will prove out to be 1/10, and the bottom one, 10 to the negative third, would be 1/10 times 1/10 times 1/10 again. So you've got 3 1/10ths being multiplied. And the incorrect answer would be to say this is 1 over 30 or 3 over 30, something like that. Those are popular wrong answers, but your numerators will be 1 when you multiply those all together, and then 10 times 10 times 10 is 1,000. Now this is a popular misconception as well. People say, oh, 10 to the 0 is going to be 0, but if you look at the pattern, we're dividing by 10 every step of the way. So you have to continue that pattern. So if I divide this by 10 right here, 10 divided by 10 is 1, so actually 10 to the 0 is 1. And that's where kind of the exponent laws come into play right here. If I can show you another way of looking at this, let's say we were multiplying 10 to the third by 10 to the negative third. And I'm just taking these numbers from over here. 10 to the third is 1,000. And 10 to the negative third is 1 over 1,000, according to what we said earlier. So if I multiply those things together, of course you're multiplying fractions, the 1,000 can be made into a fraction. Well, your numerator is going to be 1,000, and so too is your denominator going to be 1,000. And so really, this will 10 to the third times 10 to the negative third equals, well, it equals 1, and so therefore we would say 10 to the 0, which is the same as 1. If you did the same thing with 10 to the second times 10 to the negative second, you'd get the same answer. 10 to the second is 100. 10 to the negative second, of course, is 1 over 100. And 100 times 1 over 100 is 1. So we could say that this is 10 to the 0. And that's where this exponential law comes into play. So if you have the same base, and here we have 10 and 10, you just add the exponents. 2 and negative 2 make 0. And just to show you one more instance of that, if I had 10 to the second times 10 to the first, well, 10 to the second is 100. 10 to the first is 10. 10 times 100, of course, is 1,000. And the shortcut of that, if I just did keep the base the same here and add the numerators, we get 10 to the third. So that's one of those rules that we can start to memorize, is that when you add these exponents, you can get your new equivalent value over here as long as you keep the base the same. And that's only true if, by the way, these bases are the same at the very beginning of the problem. And a couple other rules to tell you about. I also want to tell you about my favorite food. I'm going to tell you that in a second. 10 to the third, let's say we were dividing these numbers, divided by 10 to the first. 10 to the third, of course, is 1,000, and 10 to the first, of course, is 10. So this would equal 100. And what we can do with the laws of exponents is actually, as a shortcut, we can just say, all right, these bases are the same, So why don't we just subtract the exponents, and that'll leave us with 10 to the second, which, oh, by the way, we got that same answer up here. So if your bases are the same and you've got a division problem, you can just subtract the exponents, and that'll get you something. So we've seen if we have 10 to the second times 10 to the first, you can just add these exponents, and that'll get you your new value. Well, if we have 10 to the third over 10 to the first, you're using division, now you can just subtract them. My favorite food, by the way, is buffalo wings. I don't know what it is about them, the spice or what have you. I've had the 99 buffalo wings for a long, long time, and I love them. But I'll even eat the ones like from Domino's or name your chain. The one I'll say this: I don't love Buffalo Wild Wings. Those wings are they're okay, but in general, like if you throw them in front of me, I will eat them. Buffalo wings are a fantastic food. Anyway, one more rule to show you about, and that rule is the exponent to an exponent. So let's say we had 10 to the second to the third. What this is really saying is we know that 10 to the second is 10 times 10 or 100. It's really saying take that and then show me 3 groups of it. So you'd have to write 10 times 10 6 times. So we've got 6 groups of 10s right here. So that'll be 10 to the 6th power. And therefore, you can start to recognize, hopefully, that the shortcut here is just to multiply your exponents together and leave that base the same. So if you see an exponent to an exponent like this, that's what you do.